Welcome back, everybody. This is our final exam review, part one, question number 3. And this problem was a problem that appeared on the Regents a while back. And so in this case, we see that it's a water tower in a picture below, and modeled by a two-dimensional figure beside it. I did not include the picture of the water tower, but it kind of looks like this, though. In this case, is composed of a hemisphere, a cylinder, and a cone. Let C be the center of the hemisphere and D be the center of the base of the cone. If AC equals 8.5 feet and BF equals 25 feet, the measure of angle EFC is equal to 47 degrees. Determine and state to the nearest cubic foot that the volume of the water tower. And so here we have, in this case, is going to be the figures. We're doing 3 different volumes. Okay, and the first volume is going to be a cone. So we have the volume of a cone. The second volume is the volume of a cylinder. And the third volume is the volume of a hemisphere. So just hemi-s, okay? And so we're saying, well, what is going to be the volume of our well, how do we find the volume if we don't know the radius? So we do know the radius, though. We know the radius AC is the radius for the hemisphere, but this radius is the same radius we have for our cylinder as well as our cone. So we know our R value is 8.5 feet. Okay, and so now 8.5. And so now we want to find the height of the cone. So to find the height of the cone, we have this right triangle here. And we know that FD, the radius, 8.5, and we're looking for the height. Well, in this situation, you have the leg opposite and the leg adjacent. So we are going to use the tangent ratio. So the tan of 47 degrees is equal to the height over 8.5. Or we'll just say the height, in this case, of the cone is 8.5 times tan of 47. Now you could find the value as is, in decimal form, and you round everything off. I would say if you can round everything off, leave in 2 decimal places. But I'm going to leave everything in 8.5 tan 47 because it kind of compacts all the decimals together. So we'll find our volume for the cone to be 1/3 pi times 8.5 squared, and our height is going to be 8.5 tan of 47 degrees. So let's find a calculator. In our calculator, let's bring this down a little bit here. Okay, and we clear all this. All right, so we have 1/3 pi times 8.5 squared, which is the radius squared. And then we're going to multiply by times 8.5. The height we found to be 8.5 tan of 47 degrees. Okay? All right. And so here we get 689.65. All right, so that's our approximate value. So in this case, about 689.65. I think we said 0.65. Did we say 0.65? 0.65. Okay, and so that's going to be the volume of the cone, just the cone. And now for the cylinder. Now the cylinder is pi r squared times height. So again, pi times 8.5 squared times the height, which is 25. Now enter our calculator. So we'll have, in this case, pi times 8.5. So I'll do parenthesis 8.5 squared times the height, which is 25. And we get a value of 5,674.50. So 5,674.50. 5,674.50. Okay? And our hemisphere is going to be 2/3 times pi times the radius to the third power. So 2/3 times pi times 8.5 to the third power. Okay, so, all right, so here we go. So we do 2 divided by 3 Then we have pi, parenthesis 8.5 to the third power. Now, I know a lot of you using calculator do this, but you really do have to write out what you're typing in the calculator should work, because the work, even though it's calculator based, you have to show where the values come from. So if you only write out the numerical values, in this case, for the volume of the hemisphere, which is 1,286.22, if you just write that out without showing where the work comes from, you're not going to get credit for it, no. So again, so you have to write down 1,000, I believe it's 1,286.22, 1,286.22. Now we're going to take all those three, and we're going to add them together. So we're going to add, in this case, I'll use blue, and so we have 6.8, so not 6.8, sorry about that, 689. So 689, 9.65 plus 5,674.50 plus 1,286.22. Now, you can add these together, but you know what though? The great thing about having everything on a graphing calculator is that you can just grab all the decimals we found. Okay, so we're gonna go up to, let's go up here to our first number, and we'll capture all the other decimals, add to it. Now, will it make a difference? It may or may not. We're rounding up to the nearest, I believe it's supposed to be our, here we're saying cubic foot, so whole number, but just in case, so hit enter. Okay, then plus, go to the second number, enter, and then plus, and then to the third number, enter, and enter that, and we're going to get 7,650.37, which round to the nearest cubic foot will be, okay, what do we see now? All right, so we said 7,650 cubic feet. This is round to the, again, nearest cubic foot. Now, will it matter if we take our decimals and then, round from there? Let's take a look though. Okay, let's go back to a calculator. Let's add in this case. Well, what if we add in this case 689.65, and we're going to add 5,674.50, and then add to that 86.22. And we add those together, we still get really 7,650.37, the same exact thing. So whether you round off two decimal places and then just use the numbers or just grab them from the calculator, that's totally good. You get the same exact rounded value. Okay, so this will be the answer for the first question. That's our volume of the water tower. Now, the water tower is constructed to hold 400,000 pounds of water. If water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? So we're going to take our 7,650 cubic feet, okay, and multiply it by 62.4 pounds. Now that'll give us a total weight, but we want to now multiply that by 85%. We're not looking for the total amount of the weight filled together, but only 85%. And so we want to see whether that works out. So we'll take our 7,650, so 7,650, multiply that by our weight of water, which we said was 62.4. So 62.4. And then multiply that value by 0.85, which is going to be 85%. And so we get 405,756. So the weight is 405,756 pounds of water. And so the answer in this case, well, no. No. Sorry, no. Well, no, it's no. The amount of water at 85% capacity will exceed the 400,000 pound limit by 5,756 pounds. Okay, so we calculated in this case the amount of water we had, 85% of that, and then multiplied by 62.4 pounds per cubic foot to translate the weight of the water. And again, only 85%, and it's very close, but it goes over. It goes over. So this is why we say in this case that it's not going to be enough. All right, ladies and gentlemen. Entire page, and so we see the entire problem worked out here. Again, this was a pretty serious problem. On the Regents, it was 6 points, which is the max number you can have for question on the Regents question. And probably in this case, the volume of the volume of the 3 volumes added together to get the single volume probably worth 4 out of the 6 points, and then the second question worth 2. So again, you have to show the work. This is good enough to be able to figure out the different values. And notice the height of the cone. I left it as 8.5, 10 to 47 degrees. If we have something like this on your final, you can do that as well too. Just show where all the work is coming from. Okay. All right. So I hope this was good. Hope that you guys, if you guys have any questions or comments, leave them in the comment section below. You definitely need feedback and all. Thanks so much for watching the video. And if you please have a chance to, please leave a like for the video, as well as subscribe to the channel to find out when new videos, and turn notifications to find out when new videos are added to the channel. Thank you so much. Make sure to watch for question number 4, the last question of our final review part 1. And then, of course, we're doing videos for final review part 2, which will have a different set of questions to look at, though. Thanks so much for watching. Take care and be safe.